Thank you for the opportunity. Professor K.F. Jung, Engineer Rules and Corp, the Organizing Committee of Hong Kong ES 2016. Thank you, Dr. Shum, Organizing Committee of Hong Kong EPC 2016. Ladies and gentlemen, distinguished guests, I'm honored today to present one of the project campaign that our company had proposed, and we're lucky enough to win the competition. Now, I would like to open up the floor by asking a couple of questions. The first one I would like to ask is, does anyone actually own any electric cars right now? From the floor? Anyone? Not yet, but you placed an order, right? Right, so you're one of the 325,000 pre-order. So Tesla actually recorded 325,000 pre-orders reportedly last week from one of the newspaper sources. But little do you know that actually 20 years ago, there is actually another mass production vehicle by General Motors. And this car is actually called EV1. So as a first generation mass production electric vehicle, they've actually shipped only 1,177 units. So to be honest, innovation is a challenge. It's always a challenge. You have to come in the right place at the right time, right? And of course, there are a lot of policies, governance model that has to go with it. So I mean, a lot of the early morning sessions we talk about policies and supporting frameworks that the city has to adopt. So I would like to now bring it closer to my presentation of SmartAirCon. Our company has been involved in the universal remote control business 25 years as a Hong Kong-based company. So we understood the challenges of what's you need to build for a universal control, smart control at home. So one of the problems that we see right now in Hong Kong when we entered the competition, and it's also part of our project, was the fact that we need to create something impactful for not just a few, but a majority of the citizens. So I'm just quoting some of the definitions. So it has to be related to urban innovations, transformation, using existing ICT infrastructures or knowledge or resources, and transforming the life of its inhabitants. So yes, having an electric vehicle and getting ready for it does take 20 years. But at the same time, there's some low-hanging fruit today that perhaps it takes shorter cycles, 3 or 4 years, maybe 5 years. And this is where we believe that our SmartAirCon can actually achieve. So these are the objectives that we have proposed. We propose that our project, our campaign can eliminate the peak demand of electricity, reduce consumers' electricity by 3 to 10% in air conditioning, and also because of reducing the use of electricity, it can reduce the emission of greenhouse gas. We will have social impact because we would like to engage with a lot of this, local institutes of educations and universities to engage in service learning. At the end of the day, our product family, we would like to make profit, but also donate 5% of the profit. Our framework engages the use of open data that is available publicly right now, and we would collect consumption data from the user. So what are we trying to solve right now? The problem that we have identified is a pretty huge problem, and we're talking about 1/3 of the electricity being consumed in Hong Kong. According to EMSD, 34% of the electricity is in residential category is consumed in air conditioning. A similar percentage has been observed in commercial as well. Now in Hong Kong, quoting Kowloon Bay, which is being picked as the smart city redevelopment area. In Kowloon Bay itself, there is a mix of residential and commercial industrial. The industrial also use a lot of those so-called split type aircons as well. So that itself is considered almost like semi-residential, the way they use it. So what we are proposing is a family of products that engage the the use of a new product, but the product performs much like a dock, and it advocates the reuse of an old digital smartphone. So the design philosophy is based on the fact that why do I have to propose and design and manufacture a new product that requires another Wi-Fi chipset, another Bluetooth chipset, extra cost of components and plastic materials, and at the end of the day, more digital waste. So it's very clearly defined that from design philosophy standpoint that it has to be reusing something that is already out there in the marketplace. Now, let me show you 3 or 4 products here. The first one on the left here is one of the recipients of the Hong Kong ICT Award last year, and also the RISE Award. It's a Hong Kong startup called MD Labs. They have a product called MD Climate, targeting at the same potential. Very admirable company based in Hong Kong. The other 3 on the other side are actually our customers, Remote Tech's own customers of using our chipsets and IR code library. All of them are reputable. From the right-hand side, SmartAC from Tado is a well-funded VC company in Germany. They have thermostat solution, they have SmartAC product, but they actually have to use our MCU, a Hong Kong-based company. The MCU happens to be a product that we work together with Jack and Trip from Hong Kong Science Park. So our philosophy is also to bring in Hong Kong-based company that we support Hong Kong tech industry. Now, in the bottom here is a Android app from an Israeli startup, actually funded by a VC fund from Cyberport from Hong Kong. They are actually ranked #1 in the universal remote app in Android marketplace, and again, they use our IR code library. And this brings us to the value proposition. Why we think that our SmartAirCon product proposition has a lot more to offer. First of all, all these 4 products today actually only talks about using Wi-Fi. So single connectivity. So Wi-Fi only. And they only cater for one room scenario. So with a product, with a line of sight, if I can control the devices, I can get access to it, I can control it. One room just isn't good enough in a Hong Kong context, or even in an American context. Because in typical household in Hong Kong, you might have 2 rooms, 3 rooms, you have a living room. So you have a lot more air conditioners. Can I ask from the floor here, show of hands, how many of you have air conditioners that are remote control, using a remote control? Can I have a show of hands, please? Thank you, sir. So the impact that we're talking about, if I may, I'm not saying Tesla is not impactful, but this is a low-hanging fruit, quick win for many people. Now, so we also advocate the fact that in order to efficiently control the climate and also have anything to do with energy management, you need to use a combination of fans as well. So unfortunately, all these products out there right now, including some of our customers, they haven't really exploited the opportunities to really target at energy management, climate control, comfort, and something green. So, using one of my favorite framework, I use Blue Ocean strategy. We eliminate the high cost of having extra chipset, more digital waste, green philosophy. We add a lot of value into it by using a smart handphone, older smart handphone that you might have put away. So you have increased connectivity. It's green because we're building a smaller dock, and I don't even have to ship an adapter, power adapter. You might already have it already. Lower BOM costs, boost of material costs. And then of course, we can connect to other BLE device. So we believe we have all the key components to make it become a successful campaign. And of course, we have looked into multi-room use case, and even in American context, on the left-hand side will be American. So because they use HVAC, we already are a HA company that ships thermostat, so we already have all that thoughts in place. And one of the value proposition is to connect to open data. the observatory in Hong Kong gives you data up to the minute. We can also connect to other API. And in future, if our two utility companies in Hong Kong are making their data available on metering projects, that becomes the feedback back to the system to control it. Remember the 34% that I talked about? That's a big problem. So if there is saving, that can be saved, this is the area. You need to know how much you're consuming, and then you want to control it. And you want some device that is smart enough to control it. On the right-hand side, we can also take inputs from sensors that is built into our dock or some of the other pubs, we call it, and then also get access to APIs from all those sleeping data that you can get from wearable devices. So the proposed solution that we had was a family of IoT products, which I'm going to show you. One of the key problems of some of these products is how much are you going to sell it for, right? In the two scenario of the two products that is targeting specifically air conditioning, they're selling at around $170 US. So if you have a 3-room scenario, you're talking about over $700. Whereas in our proposed solution, we use a combination of the dock as well as pubs. It will be only $95. Now this all goes back to our capability, and that's one of the reasons why I would like to advocate about standardization. We have been doing infrared codes for a long time because we have been running this type of business for 25 years. So what happened is we've been actually working on standardization ourselves by implementing our own data protocol with different chipsets companies. And we were lucky enough to have we call it Universal Infrared Descriptor, URID. And this descriptor, we have actually published it under Creative Commons, and we have actually give it to different chipset companies for consumer appliance for them to use. One of the very significant adoption came from one of the biggest cable operating company in US. They have actually shipped over 30 million units using this protocol, which is RF or CERC 2.0. So a lot of these protocols data are being stored that way. Now we believe that this standard can now become a de facto standard, and maybe even a standard that perhaps the whole industry can follow. We've built along that line our own database library, IR codes, infrared codes of different manufacturers, different brands, different consumer devices. It's a very complicated ontology of data sets, and you really need the data scientists to look into it. And in fact, this is a project that I'm trying to work out with one of the universities here in Hong Kong. So we have the capability. We've built for last 5 years, a comprehensive cloud-hosted IR code library, and that enables those companies that I've just mentioned, our customers, to be able to enable them to push out products in the marketplace for smart controls. And this is the process that my team back in the back office. It's a very comprehensive business process, but we live by the fact that in order to be able to trace back every footstep, you have to need a very comprehensive business process. And that includes even reversing it. That means if I have a code, I can trace back which, for example, which remote controller it comes from. Now we get all these remote controllers from our strategic partner, from our customers. Sometimes it will be a TV company, it could be a set-top box company. They actually give us all these, and we also source it ourselves from the open marketplace. So we are very much like a Google map. We are reverse engineering everything around the world, and we make it add value to it, and we're creating that value for all these other developers. Now to this, we are very happy to announce that we will be happy to work with Hong Kong Science Park to actually open up some of these data for students to develop projects. And we're going to work with other academia institutions to perhaps motivate more engineers to learn more about smart home or smart controls. So for this project, our engineers have basically completed an engineering sample of the dock. So this is just the block diagram. We've actually used a chipset from Dragon Chip, which has been proven with all these other products. We have an app or a reference app already designed that can add different kind of brands of devices, and it goes to our cloud-based code library, retrieve the brand and the model number. On the top right-hand corner, you can actually see the room temperature. That means it's the sensor. Yeah. So it's actually shown here on the bottom right here, and then it will change the temperature. So you need to know the outdoor temperature and the indoor temperature. You can also add humidity into it. So the whole value proposition is that we bring down the cost using a handphone, as shown here. Okay, a lot of you might have spare headphones, and for data privacy reason, you don't want to trade it. It stays home, right? This can be put in good use, and by doing that, you actually help conserve, save our environment, because you're not buying something that totally reinvent in the wheel. So there are many use cases. For example, using it together with fans. So we have some complicated calculations on how to save energy. My team has worked out through some different cases from universities. Some of them are published. Some of those benchmarks are published by, for example, here CLP. I want to give an example on why our thoughts are slightly different. First, you need to understand that our body temperature changes, our requirement, personal comfort requirement changes throughout the day. But most of the time, the remote controller is very, very dumb, and nobody actually knows how to program it. Now, the fact that you can actually smartly program a profile is still not good enough. What is good enough, what is better if you live in one block, say in Taikoo Shing, and if there are enough of such products being adopted and marketed in the marketplace, all I need to do is to find out, okay, well, who is using Hitachi air conditioners in Taikoo Shing? Maybe the profile's already been programmed by someone else. I can just borrow the profile. So it's almost like sharing a template, right? Once you be able to find out the top 10 profiles, and we have analytics to actually show you how efficient some of those are, you can actually save energy. Now, this is a case scenario of the use cases is when we fell asleep, our body temperature actually rises about 2 degrees Fahrenheit. This is according to Harvard Medical School. So this is why we always need to cover up something, and we feel cold in the morning. In this case, in this scenario, perhaps at around 6 o'clock, the air conditioning will be programmed to shut off, but your fan is programmed to switch on now, just to circulate the cold air. Yeah. So there are scenarios like this that can help. And you might ask, how do I know that when to wake up, when to go to deep sleep? Well, this is why those wearable products are very good. They are now sharing the sleeping data. When you go to deep sleep, they actually give you up to the minute sleeping data. And there are already products out in the marketplace that actually measure the body temperature for babies. And this is very good application, because you neither want it too cold or too hot for babies. So again, the data can work very well. Not because of the environment temperature. It's actually the temperature felt by the subject. So at the end of the day, there are some mathematical formulas that actually suggest the combination of using fans and AC, and ESMD has been promoting it, how to be energy efficient. And based on that, we calculated that it could be up to 3 to 10% savings in the consumer electricity bill. In Taiwan, there's also a research from a Taiwan professor that actually have successfully used infrared controller. It was hacked together, but it has worked well in the quantitative study. In US, there are similar programs where they add in smart thermostat as well for energy saving for HVAC, and Pacific Electric gas and electric, actually subsidized about, I think it was 50 US, yes, 50 US dollars for any installation of that smart device. I'm not suggesting, but this could be a direction that perhaps utility company or other agency can support and make it happen. So at the end of the day, smart devices are getting very popular around the world to try to solve the problem. We're not there yet. We believe we have a solution to the problem. We hope that we can bring up to the market at a very good price, and at the end of the day achieve these objectives, and together hopefully we can bring into the smart city one component where it's actually a low-hanging fruit, a quick win, and something achievable. And I think with that, that's all my presentation. Thank you very much.
Thank you very much, Mr. Zhong. Please remain on the stage. So are there any questions from the floor first? Okay, we have two questions from the Smart Q&A, so I'll try to merge it into one. So how is the SmartAirCon to be deployed to industry application like data centers?
So the question is actually related to how do we actually deploy and using data centers, right? Our service, SmartAirCon, actually have to use extensively as set of cloud and mobile solution. At the end of the day, a lot of the profiles has to be backed up to the cloud. So inherent in itself, it actually relies or dependent on the use of some of the data center services available in the marketplace.
Okay, so the second one is, it's great to have a generic remote control for different brands of the air conditioner. Will it be also good to include some authentication processes before enabling the remote control for the security concern?
So this is security and authentication, right? Oh, actually there are two. This is actually slightly two areas. First is to how do we identify a remote control. It's a certified one, and what it's emitting is actually controlling the end device, end consumer device. So this is related to validation. So what we do is we validate the infrared code by actually going to the original company. They ask them to check those. So this is a validation process. In terms of security, infrared code right now, it's very one-way. There's actually a lack of two-way, and this is actually inherently a benefit, but also a disadvantage. The benefit is that I can't control my next door neighbor's channel or air conditioners. Yeah, unlike Wi-Fi, Bluetooth, where you can actually penetrate walls, etc. But at the same time, there's a line of sight issue. So I hope I answered that question in terms of security.
Okay, thank you very much, Mr. Zhong. Thank you. And please, Mr. Zhong.